Let's look now at the question of the difference between the treatment and the control hospitals and the extent to which medical errors were reduced by the treatment, and assess whether or not that difference between the treatment hospitals and the control hospitals might be due to chance. Look first at the actual data for the control hospitals. Okay, let's look at the data for the control hospitals. And I have written it down on cards here. Each card represents the error reduction for one hospital. For example, in the upper left, one of the hospitals reduced errors by 1. And we've got all 25 hospitals listed here. And the average or mean reduction in errors was 1.88. In other words, almost 2 fewer errors in the control hospital over the prior period. This is a reflection of the fact that even though you're not actually making any changes, the mere fact of studying a phenomenon can affect it. And let's look at the treatment hospitals and their reduction in errors. And similarly, each hospital is represented by the data on one card. In the upper right, you can see that 9 represents one hospital that did a really good job of reducing medical errors. They had 9 fewer errors from one period to the next. And the average reduction in errors was almost 1 error more than the control hospitals. The mean reduction in errors here was 2.8, whereas it was 1.88 in the treatment hospitals, in the control hospitals. Keep in mind that we're talking about reduction in errors, not the actual number of errors. Now the question that comes to mind is whether that difference might be due to chance. And by that, we're going to define that as meaning, suppose we put all these cards into a hat together and then dealt out the cards in 2 groups, one of 25 and another of 25, and then calculate the average for each group. If we routinely got a difference between the groups, as big as this observed difference, then we're going to think that that observed difference might be something that's due to chance. Okay, so I have a hat here. We could use a box or anything that contains all the cards, and I'm just going to scoop the cards into the hat. And then do similarly for the control group. And then the key thing is, without looking at the hat, I'm going to shake it up and draw out cards for each group of 25. So there's one for that group. These are being drawn at random, of course. There's a card for that group. And we're going to draw out another card. We get a 2. And we get a 2 here. Let's do a couple more. And I'm going to do this for all 50 cards. Let's do that off camera. Actually, I'll come back and finish that. At the end of our first round of shufflings and dealing out, these are the results we get. And you can see as you look down that the average for the first group of 25 was 2.36 errors reduced. And then if we look at the second group that was picked randomly, the average for them was 2.44 for a difference of 0.08. Let's record that. 2.36 minus 2.44, and that's a difference of minus 0.08. And recall that the observed difference, we'll just note it down here, was 0.92. All right, I guess we need to do another shuffling, and we'll do that now. Okay, let's do another shuffling. We'll gather all the cards and put them into the hat. Okay, here we go. Okay, we'll deal out these. here are the results of our second shuffling. The first group had a mean of 2.12, and the second group of randomly shuffled 25 hospitals had a mean of 2.56 after we dealt them out. So let's see what that difference is. That's 2.12 minus 2.56. That's minus 0.44. Is that right? Yes. So on both our shufflings, we didn't get a result as great as the observed result. But we really need to do this lots more times, and we'll do that with a computer, to get an idea of how extreme that 0.92 is.